Okay, hi. Good evening to all. So I hope you guys can hear me loud and clear.
Yes.
Okay, perfect. So, okay, so great. And first of all, thank you all of you guys. So to be part of this session. So basically, what we are here today is to discuss about one of the mostly and a popular and I would say emerging machine learning technique used in the industry called support vector machines. So broadly, in terms of today's agenda, so we would like to understand basically what is exactly a support vector machine. So so possibly some of you guys have heard about it, some of you have not, and maybe some of you also know it, and maybe some of you have been applying it. So I would like also to have understanding from you guys about your maybe awareness and even the understanding of SVM. So yeah, so that is in terms of putting through today's agenda, and also once we broadly understand in terms of what exactly is a support vector machine, then we shall do a real case study on it, and we'll try to understand that how to apply the same technique in R, and we'll try to basically integrate the understanding into application. So which is very important in analytics industry. So yeah, now just moving on from the agenda of this session. So I would like first of all of you guys, if you can just introduce yourself. You can introduce your name and your academic background and where you are working. Are you a student or you professional? You're working in analytics industry or a other industry, and that would be great. So you can pin down your intro in the chat box. So that would be very. I would be really curious to know all of you guys. Yeah, surely. So on Thursday evening, so we would like to also because I think it's very glad I'm very glad in that way that uh, you guys and I share the same passion for analytics, and possibly that's the reason both of you uh, are on this platform right now and talking about it. So if you guys can really quickly introduce yourself, and I would take that time uh, to introduce myself. So my name is Arpindu Ganguly, and I am currently part of the advanced analytics team in Accenture, marketing analytics, which is part of the Accenture Digital. And I have got almost 3.5 years of experience in analytics and diagnostic consulting. And in terms of academic background, I did my graduation in economics from Ramdas College, Delhi University, and then pursued my post-graduation from Department of Economics, University of Calcutta, again in economics. So yeah, that's briefly about me. And currently, I'm now located in Gurgaon. So yeah, I see a few of you introducing yourself. So Abhishek, yes, you said hello, and possibly you will write your details. So Vijay is a BTech, great. Uh, Zaban is a computer engineer from MIT. Okay, so you are a fresher. Okay, Ranjan, you're working in TCS for the last 3.5 years as ETL developer. Okay, great. Because you're working in Genpact as a process analyst, okay, you're a graduate in physics, chemistry, mathematics. Anupam is a chartered accountant. Oh, great, with 12 years experience. So Anupam, I think you have the highest experience till now, until anyone else who introduces himself or herself with greater experience. Abhiroop is a BTech, okay. Abhishek is also working in Genpact and is an MBA. Okay, okay. Okay, so yeah, feel I think people who are joining in, you can still introduce yourself if you have not. And why don't we get started? Um and yeah, feel free to ask me questions in the chat box, and I will try to respond in the most informative manner, if I put in that way. Yeah. So basically, I wanted to ask you first question that let's talk about a broader concept of machine learning and artificial intelligence. So possibly and analytics. So possibly all of you guys must have come uh, across this term of machine learning, artificial intelligence, deep learning, and analytics. So and in this plethora of words or techniques which possibly you have been using or you have been hearing about. So we come across we come across various names. So some of the common names are like regression. Uh, there are like forecasting. So some use predictive analytics. So there are various terminologies associated with analytics per se or machine learning per se. Yeah. Uh, Before jumping into a particular technique, which in the today's agenda, which is SVM, so I would like to also take this opportunity to just uh, bring you the concept that be it analytics, be it big data, be it deep learning, be it any kind of statistical modeling. So we, at the end of the day, we are all working for a business, and we are all working for a certain client need. And the most important thing, possibly, which sometimes we try to maybe give less importance to in terms of analytics and machine learning, is in terms of the idea, or is in terms of relating the data to insight. So so I always recommend, and I always keep on telling myself uh, that any kind of machine learning technique or tool that you have been learning or using, so let's say R or Python, or a technique like a linear regression, logistic regression, forecasting. So they all should, at the end of the day, make a business sense. And uh, yes, it's a machine and it's a learning, but you should have the idea behind it, as in why you're applying it and what would be the takeaway from it. And it should not be just a mechanical statistical approach, or a learning approach. Yeah. So that is something which I thought, like, you should always be aware of, always be cognizant of. And uh, having said that, uh, I will now bring you the concept of SVM, and how it basically plays a role. Yeah. In the analytics industry. So uh, yeah. So basically, support vector machines. So any of you guys, if you have any questions before I get started. So I think Vikas had a question. So any of you want to ask any question before I really get into the session? Anything else you want to ask to me before we get started with this? Okay, maybe I will assume the temporal silence to be a no. And so let's start. Let's start with session. So yeah. So so basically, I would like to put down the agenda. So basically, what we'll try to cover in the next 60 minutes or so is what exactly is a support vector machine. We will try to do a practical case study in R, and I will try to make you understand what is the scenario and what is trying to achieve using SVM technique. And we'll try to analyze the result that we get from the modeling, and we'll try to, and feel free to, like, ask as many questions as you want, and I will try to answer them all. So yeah, before I get started in that, so all of you guys, do you know what is do you guys have heard about support vector machines, or have any kind of idea what it is or how it is used? Anything about? apart from the fact that SVM stands for support vector machines. Okay. Any one of you who has any idea about it? Okay. Okay, fair enough. I think maybe the majority seems to have a limited idea about it. So it's a great thing to know something new. Yeah. So I'll try to present it. Yeah. So Aditra has got understanding of it. So yeah, uh, somewhere near, right? So yeah. So basically, a support vector machine is a kind of a supervised machine learning technique. So there are three words here: supervised machine learning and a technique. So basically, it's a technique. That's basically a process, a approach, and machine learning. Machine learning is basically it's kind of analytical technique, a statistical technique. Yeah. Machine learning. When we use the word machine learning, it means that it keeps on doing at n iterations and tries to give you the best result. Yeah. It's just not like the one iteration and I stop, but it's like a repeated iteration, and the end objective is to give you the best result. And I will describe what exactly a result means. And what do you mean by supervise? So in machine learning or in analytics, supervise is something as the word suggests, so supervising something. So here basically we have I will discuss you. I'll give you a more detail about it. So supervise technique is kind of a technique in machine learning. It's a superset of techniques. So basically, supervised learning, machine learning means so any kind of a uh, technique which has a dependent variable. So any kind of technique which has a dependent variable is called a supervised machine learning technique. Yeah. So and what I mean by dependent variable is basically a variable of interest. Yeah. So something like you want to maybe predict sales of a company, or maybe predict that whether a customer will. So, for example, all of you guys are maybe using, let's say, Ola or Uber. Yeah. So if the company wants to predict that whether you will keep on using it, the particular service. So uh, there is a response variable, right? So in that case, that is also kind of a supervised machine learning technique. So anything which has a prediction or a direct response variable, so that is called a supervised machine learning technique. So you can read about it. So what exactly are supervised techniques, and there are multiple techniques which comes under supervised ML techniques. Yeah. So coming back to SVM, so it's basically works for both classification and regression. So what it means is that a classification technique is basically when you want to classify a certain outcome. So a outcome which is like, let's say, for example, mostly you are working professionals. So let's say the tomorrow outcome is about you going to your respective offices. Yeah. So it will be a binary outcome, right? So either you go or you do not go. Yeah. So classification techniques mostly caters to your response variable, which has categories. So in this case, I'm giving an example of a binary category, right? So the output is like, for example, if you want to model, if someone wants to model that whether you will go to tomorrow's office or not. So it's like a binary outcome, either you will go or not go. So that's a classification technique. Regression is mostly in terms of when we have a continuous variable. So, for example, as I was giving the example of sales. So, what are the factors which possibly will explain the sales of a company? So, in that case, mostly this regression technique is used. Yeah. So it works for the SVM. The speciality of support vector machines is that it works for both classification as well as regression techniques. So if you guys have heard about any other analytics techniques, there are specific techniques which gets applied to regression. There are specific techniques which gets applied to classification. SVM in itself gets applied to both the techniques. Yeah, but it's mostly used for classification. It's greater use lies in the classification, given the idea that it serves, right? So now I will try to explain you. I will go from this presentation mode and I will try to make it more live in terms of explaining what SVM is. Yeah. So first try to understand, or let's try to understand what SVM is. So in a support vector machine, so there are these words, right? Support vector and machines. So machines, you can just relate it to something like which is related to machine learning, which is basically helping you to build the model. Yeah. So what it is basically what a support vector machine is. So let's say I have three variables, uh, which is let's say maybe okay, you or maybe the probability of, or let's say y is a variable, and it's basically a 0 and 1 variable. Okay, so it can either take 0 or 1 response. So these are the two responses that it can take. And let's say we want to explain the behavior of y, or maybe predict y with respect to certain variables, which basically helps us to predict. So let's say these are called my x variables, and let's say these are called my independent variables. So if you want to take an example, let's say a customer defaulting in a credit card. So either he will default, let's say 1, or he will not default, let's say 0. And there are various variables which helps me to predict whether a customer will default or not. So let's say his back history, how much credit he has taken, his savings, and so on and so forth. Yeah. So now coming back to SVM. So what a SVM does is basically, so you see this red dots and green dots. So basically, these are my y variables, right? So these are basically either my y take like 0 and either 1 with respect to my x's. So the SVM is about bringing this picture of distinguishing between my zeros, which is basically guys, these guys basically, and also distinguishing between these guys, which are the red guys. Yeah. So the SVM basically tries to classify or distinguish between these two, and by helping or by getting certain independent variables. So with respect to certain independent variable, it basically tries to have this kind of a line, which basically disintegrates my green and the red dots in this case. Yeah.
Excuse me, sir.
So
Excuse me, sir.
yeah.
Yeah, yeah, sir. Sir, which among the two is zero, and which among the two is one? The green or red?
Okay, so so this is just for illustrative purpose. So you can take it as 1, you can take it as 0, and this you can take it as 0, you can take it as 1. Yeah, so either of the two. So I've just used it just for illustrative purpose, and so it does not really impact that यहाँ पे भी zeros can be हो सकते हैं, ये भी one. These variables can represent the event happening, y event happening given by x, or this can be also be the y equals to 1. But the point is, by basically my objective here is to basically distinguish, yeah, between an event happening or not happening, given my certain variable. So let's say I have just one variable and I want to predict whether event will happen or let's say not happen. So what is the exact point which will or help me to decide that whether an event will happen or not happen? So basically, SVM tries to distinguish between the two categories. Here, I'm basically talking about binary classification uh, with the help of my certain independent variable. Yeah. So this is basically in terms of concept. Now there are a few things which you would like to understand and know. Few of the nomenclatures, which is very important to understand. Yeah. So so if we have like kind of a n-dimensional features or n-dimensional variables, so it tries to plot your dependent with respect to each of these features, and it tries to find the optimal hyperplane or a plane which basically segregates the two classes of y equals to 0 or y equals to 1. Uh, so so if you see the slide, yeah, so again, that's a representation of the same thing that I had shown you in the Excel. So let's say these are like the blue dots, which will represent one category of my dependent, and these are the red squares, which represent the other category of my dependent. So basically, a support vector machine tries to find this optimal hyperplane. Yeah. So this center line, and these guys, these are called the support vectors here. And the objective here is basically to have the maximum margin or the distance between the red square and the blue circle. So basically the modeling, or basically the objective here, or how it tries to distinguish, is basically trying to draw a line between your one class of variables of a variable, which is your y, and the other class of variable, which is here in this case is blue, and trying out to find the optimal hyperplane. So hyperplane is just a line 2D on 3D. In higher dimensions is called the hyperplane. So when we have n dimensionals, so we will have we will have a hyperplane, and it will not just be a line. Yeah. So it's basically, SVM helps us to find a separating boundary. So in this case, it basically separates my blue circles with my red squares, and it tries to achieve by maximizing the distance between the two hyperplanes, so which is like these two points, and the distance between these two are called margins. So these points which lies near closest to the hyperplane, these are my support vectors, and this like the optimal hyperplane. And what a SVM does is basically declassifies or tries to disintegrate my two classes of, here I'm talking about classification problem. So let's say a y equals to 0 and y equals to 1. It tries to segregate between the two given my axis. So if I get back to a few examples of it, yeah. So let's say I have this y here, and I have this x here, yeah. So and I've tried here included three kind of hyperplanes for you. So there is one A, and there is a B, and there is a C. So now can you like just pinpoint from understanding this picture, so which would be the right hyperplane in terms of like segregating the two outcomes of y, which is, let's say, the star and the red. So there's a quick understanding or quick understanding check for you guys. So what would be the right hyperplane? So this is like my A, B, and C, yeah. And so according to you, which should be the right hyperplane? Yeah. So the has says it's the B1. Okay. Okay. So guys, whosoever is there, so which would be the right hyperplane here, disintegrating between these and these guys? So we have the A, B, and C. So I'm awaiting a few more answers. It's a very easy question. It's a very visual question, yeah. So so what would be the right hyperplane for you? So which disintegrates between the blue and the red one? Will it be is it better, Abhishek? Okay. 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 Hyperplane? Sure. So hyperplane is basically a line which uh okay, yeah, sure. Hyperplane is basically a line which tries to distinguish between your two classes of output, which is basically your y equals to 0 and y equals to 1. So again, coming back to the fundamental problem, what we're trying to achieve is that, let's say we have this uh, so just let me know, guys. So yeah, so basically I'm talking about a dependent variable, and there are two possible outcomes to it, right? Is 0 and 1. So let's say this is like the y happening, y, yeah, and this is like not happening, yeah. So now we want to
Sir,
predict, yeah.
sir, yeah, sir, I didn't get the graphical interpretation of the zeros and ones here.
Yeah.
So yeah.
Go ahead. Yeah, you want to ask
Sir,
something? Yeah.
yeah, sir. Sir, how's the interpretation represented graphically here? How's the interpretation represented graphically here, sir, of zeros and ones?
Okay. So here, let's say these guys. If I again try to Yeah. So these blue stars, yeah. So let's say they represent your zero here. Okay. So these blue stars, they represent the zeros, and let's say the one represents the red circles. Okay. So the point here I'm trying to make is with respect to the two categories of outcomes, yeah. So which is like the red circles and the blue stars. So how am I analytical technique would try to distinguish, or how would you like to disintegrate, or you want to predict whether it should be a star or whether it should be a circle. So you want to build a model or which basically clearly distinguishes between your 0 and 1. Yeah, you want to find those x's, right? So if I just try to explain you this classification thing, it's basically, let's say these 0 or stars represent scores, okay, or great marks, and the circle represent, let's say, 100 marks, and this circles represent, let's say, 0 marks. So, and these are marks of students. So now you want to try to analyze that which are the variables which basically explains that whether a student will get 100 or let's say a 0 in an exam. Let's say there are only two extreme values, and you want to identify this 0 or 100 with respect to certain independent variables. Let's say time of how much time the student is studying. Okay, here's like maybe distance from the school, and so on and so forth. There could be multiple independent variables. So what we're trying to analyze with respect to certain x's, I want to predict whether it's a 0 or whether it's a 1. So coming back to this hyperplane concept, so this hyperplane or this support vector machines, what they do is basically tries to declassify or find the right hyperplane or the right segregation, which between the two classes of output, which here is 0 and 1, and let's say the 0 represents the stars and the 1 represents the lead circles. So which is the optimal hyperplane? So whether this line should be here or so basically, so where should the line, whether the line should be here or whether the line should be here. So here the objective is to find where exactly the line should be, right? So which basically tries to optimally divide between the two classes of output. So that is basically this concept of SVM. So how do you basically distinguish between the two classes of output? So if you see on the right hand side, I have like three hyperplanes. Okay, so my B, C, and A both distinguishes between the two classes of output. But here, in terms of the distance between the two, it's the C hyperplane, which is basically has the maximum margin. So here, for example, for B, this margin, let's say, which is basically this margin, the margin between the hyperplane and the star is this, right? Somewhere around this. And from this line, the distance between this is somewhere around this, which is kind. So this is kind of low here, but this is quite long here. So in the similar case, for the line A, it's somewhere, it's very near here, and it's very far off from the blue stars, right? From the line. So here again, the optimal line is the C, which basically has got the maximum distance between the star and this kind of red dots, and here, which is basically the two classes of output, which is like 0 and 1. And if you again try to see the next scenario, where I have again a few stars which represent the one class of output and few of the circles out here. So here in this case, even though at the first hindsight you will believe that B could be the right hyperplane because it has quite a maximum distance between the two classes of output of my Y, but still A does a better job, but because it here, the classification or the misclassification is 0, because all the blue stars which represent, let's say, 0 are lying on one side of your hyperplane, and all of my like the circles are lying on the other side of the hyperplane. So basically you try to find out the exact line from which tries to distinguish between the two classes of output. So that is basically what a support vector machine tries to do. And there, as I said, so these guys on the corner, these are like the support vectors, and this is like the hyperplane. And so when we attach the hyperplane, the support vectors, this comes this comes into the concept of an SVM, or a support vector machine. And ultimately, the idea is to find out the optimal hyperplane, which basically tries to maximize the distance between the two classes of your y output, which is here, which can be 0 or 1. So so any queries? So maybe I also try to introduce you to this concept of kernel. So let's say the great advantage of support vector machines is that it can be even applied to non-linear problems, right? Where they are like non-linear separable data points, like these data points. These are not following a linear pattern. So support vector machines handles these kind of non-linearity, like a regression or a logistic. They basically tries to work on linear features, right? But a support vector machine also has the advantage or the capacity of handling non-linear dimensions of my independent variable through a kernel function. So it basically tries to transform my independent variables in such a manner that it is able to segregate. So if you see that even it's a non-linear data points, but still the hyperplane, which is like the circle, it tries to distinguish on the outer side of the circle are the blue ones, and on the inner side of the circle are the red ones. Yeah. So the two classes of output again. So this again is achieved through the kernel function of SVM. So which basically gives the advantage of handling non-linearity in case of analytical or machine learning problem, which a linear regression cannot. So or a logistic regression maybe cannot accurately. So SVM is kind of advanced machine learning technique. It's not one of the fundamental or most the easier learning technique, but it's considered as one of the more advanced techniques in today's industry, and still it's not has been used in a very I would say in a production manner, but still because of its accuracy power, it's still being used in kind of a more of innovation or a R&D stage. So that is basically in terms of what exactly is a support vector machine. So if you just try to if you want me to summarize this, so support vectors or it's nothing but it basically are the points on your through of your axis, which basically supports a hyperplane. And what is a hyperplane? It is just a line, right? A line which basically distinguishes between the two classes of output, which is, let's say, a y equals to 0 and y equals to 1, and you need to find a hyperplane which basically distinguishes between your red, uh, which is here, let's say the y equals 1, and let's say this is y equals 0. So it's basically finding the hyperplane and where exactly it should lie in that space. So a support vector machine works uh, in that movement, which tries you to very squarely segregate between your two classes of output. And if you try to give an interpretation of that, so let's say if I want to again predict, let's say as I was telling you, so predict of something y equals to happening or not happening, given my x's, so it tries to distinguish between my zeros and ones with given my x. So given my x's, what is basically which are the x's? It basically helps me to segregate between a y equals to 0 and y equals to 1. And using this, I can what is the outcome that I get is that I can predict that it basically learns from this the data, and if you again feed on the data, it can predict that given my x's, that if I just supply the x's, right, I can predict that whether the y will be equals to 0 or whether while v equals to 1. So that is basically the functionality or the advantage of SVMs, or that is what we try to achieve through SVM. It's a machine learning technique, and it is low on a interpretation power, but it is very high on the predictive power. So that's one of the drawback of SVM, because it's kind of a black box technique which is not very interpretable. It's low on the interpretability side, but in terms of prediction, it stands very high as compared to other analytical techniques like logistic regression or maybe even random forest. So that's the basic, or one of the greatest advantages of SVM. Yeah. So basically it tries to distinguish, and the idea is all about using the axis to find out the optimal line which distinguishes between the two classes of y, which is here we are talking about a binary classification. Okay. So and anything we want to ask before I introduce you with the case study. So did you get the concept of SVM? As asked earlier, how it is different from logistic regression. Okay, so Zarul, if you know about logistic regression, so logistic regression basically works on a sigmoid function. The entire methodology of logistic regression is different. Basically, here in logistic regression we have something like an equation of we try to find out the probability of y equals to 1, and through an equation of like exponential of z by 1 plus exponential of z, where my z is basically a linear regression function, which is like beta 0 plus beta 1 x1, right, plus beta 2 x2. So it somewhere brings a linearity agenda, or the linearity dimension in your modeling, right? So a kind of logistic regression basically works on this, which is basically on this logistic function, yeah. But a support vector machine does not follows a parametric approach. It basically has got a non-parametric approach, and as I said, it tries to find out through the optimal hyperplane of segregating, and not a parametric approach where you have the exponential of z, where z is equal to your additive of your independent variables. And so this is basically a logistic regression, and this is how it. And if you have if you know about the sigmoid function, which is basically the S-shaped curve, so that is how the logistic function works upon. But the methodology of prediction is entirely different in support vector machines, even though both of them are trying to do the same thing. But in terms of the methodology of approaching or predicting is entirely different. I hope it's clear, Zubran. Okay. Okay. Anything else? Anyone you want to ask? Any questions on like the concept part of it? So again, given the constraint of the time, I wanted to introduce this concept in the most I'd say visual manner to you guys, rather than getting into details of a kernel function or a margin or the support vectors. There is a lot of literature to read through, but basically the idea is about distinguishing between the two classes of output, finding the optimal hyperplane. So that is what the support vector machine does. But definitely there is a lot of a mathematical literature or statistical literature behind it. But given the constraint of the time, and just even because it's an introductory session, we just wanted to keep it in a much more simpler manner. So yeah. So if you want to read through, if you drop me email IDs, I can send you certain resources or PDFs which you can get and give you a more better understanding of it. Okay, so if you guys do not have any questions, what I will try to introduce now is about a case study. Yeah. So let's try to understand or try to implement a support vector machine in R, which is kind of a statistical learning package or statistical learning tool. If you have heard about SAS or R, so guys, have you heard about SAS or R or Python? Yes, Abran, I will give you right now. Okay. So, okay, so it seems like all of you have, most of you have. Okay, so R is kind of statistical software. It's open learning software, and we will try to implement this SVM in R and try to understand and try to analyze what the result is and how much the predictive power. Yeah. So here basically I am using this data set called spam base, which comes from the UCI machine learning repository. It's basically, it contains, I'll show you the data. It basically so you all of you guys possibly receive certain spam mails. Yeah, that for example you have uh, won so much of lottery, or you won this ticket, or something like that. So these are like spam emails which hits your inbox. So this SVM is basically used on that data to predict that whether the email which hits your inbox is whether a spam, which is like just a irrelevant trash email, or ham, which is like a relevant email. Yeah. So basically, here my, I would say a one, basically would be like so here my one is basically that whether the mail is spam, okay, and y equals to 0 will be like the mail is non-spam, right, or a ham. Okay? So basically the two classes of output that I have here, and my objective is here is to, like, I should make a model which learns from the data which has access, let's say certain variables, and using those variables it can predict that whether if I supply more variables, it can predict that whether a mail that comes from is whether it's spam or not spam, right? So that's basically the case study that we'll try to do right now. And if I just show you the data, so this is the data that we have. So basically, at the end of this data set, or the last column that we have, so basically this is my dependent variable. So if you see this column, or if I just show you this column, so it has this two outputs, which is 0 and the ones. The ones are the guys which are like the spam emails. So for the spam emails, as well as for the non-spam emails, which are like the zeros, I have this list of features. Now, what are these list of features? These are like the attributes of the email. Yeah. So these are like uh, the various frequencies of the word, like make, address, all, hour, over, remove. So it's like in each of the email, what is the frequency, and these are so this is like these are like the first 48 attributes shows the frequency of a single word in the email, right? So how much a single word is repeating. So usually in the spam emails, it will be that the word like money or like your address, it will get repeated. Please send money. So there are certain typical words which gets repeated. So based on that, those features of your email, we would like to predict that whether a email that is hitting your inbox is a spam or not. And if the object is basically that if you know using these features that whether a email is spam or not, you can basically analyze through these features. If you just use features, you can basically predict the you can predict that whether it should be a one or whether it should be a zero, right? So basically using these features, I want to predict my y, which is my dependent variable, which is basically a zero or one. And one represents here a spam, and in a zero represents a non-spam or a ham. So this is basically the data that we'll try to work upon and try to analyze to see that whether my model is able to predict it accurately or not. Any queries that you have regarding the data or the objective here? Here, basically, Hitesh, we have 58 variables. So if you see my data here, so in total there are 58. So of which we have 57 variables which are independent. So we have got 57 independent variables here. So using these 57 independent variables, we will try to predict my dependent variable, which is either a spam in case where y equals to 1 and y equals to 0, where which is non-spam. Okay, so let's get back to or let's proceed to the next phase of this session, where I will try to introduce or will try to build the model in R and try to analyze the output. Okay, so this is like the R window, which is basically the R Studio. So for guys who are like new to R, or the guys who already know it, possibly know this kind of this environment. So this is basically the tool to build the SVM model, and we do not really try to do it on pen on paper. We have a proper package or a tool to do this. Okay, so for running SVM in R, there's certain packages that you require, especially the Kernel lab. The DOMC package basically to so since SVM is a machine learning technique which works on like repeated calculation iterations. Uh, so in that case, this DOMC package, it helps you to just fasten the process. And CA tools is, again, it's basically, I've tried to explain what CA tool does. It basically splits the data into something called a training and a testing. I'll try to explain you the concept of what it is also. Carrot is also the package which helps you to do the same. Okay, so this basically these two chunk of codes, it tries to set the working directory. The working directory is nothing but where my data is kept. So basically my data is kept here. It's basically, this is the file where the original data is here, and so is the data, right? So this particular location is accessed by this particular working directory which is here. Okay, the next steps, I do not do anything. I try to activate these libraries. Okay, these libraries are important to run the SVM in R. So what the role of these libraries are? It basically gives you certain functions which enables R to perform a support vector machine technique. So that's the broad role of these libraries in this context of this exercise. The third step is basically reading the data. So you obviously need to read the data. You need to bring the data into the environment, into the statistical environment on which through which you need to apply. And so in the first line of code, we basically read this spam-based CSV, and the string as factors as false, header as false. We're trying to basically do not use the header. So my first, if you see my data, so this is the data. It does not has header in it. Okay, so there's no data header in this data. So that's the reason I'm doing header as false, so that it does not take the first row as the headers. So I have the basically the column names in a different file, which is basically this names file. So this is the names file, which is this. And through this file, I basically try to import the names of the variables. And if you see the head of the data email, so these are like 58 variables. So these are like the head basically shows the 6 of the rows, and this is for the 58 variables. And similarly, if you try to see the structure of the data email, so these are like all the 58 variables that I have. So all of them are like have been read as integers, which is fine for me. Okay, so this basically bringing the data in R and just seeing that everything is fine or not. So I'm just again seeing the head of data name. So these are like the first 6 words. So basically this data that I was talking about. So this one. So these are the column names, and they are in a separate file. Okay. through this line of chunk of code, I basically apply the column names to the respective columns of my. So basically, it picks up the row from my data name and it applies it to my data email, which is basically the original data. So it tries to basically picks up the name from my names file and tries to just plug it in the data file. So now if I see, uh, I have the column names, and if you just see the head of my data email right now, so it has the column names right now, so which initially was not the case. Okay, so basically what we did till here is we set the working directory. This was the first step. We brought certain libraries. This is the code just to have the install the libraries if you do not have. Since I already had the libraries, that's the reason I am not installing it again. And the third part is basically we try to read the couple of data sets. The first data set which had the columns, the only the data, and the other was about having the columns or the column names. And then we just plugged in the names of the columns in that data. Okay. So if you remember, the dependent variable here is basically a factor variable, right? So it can either take the value of a 0 or 1, right? So it has two classes, either a 0 or 1. So in that case, what we try to do is that the initial class of my data of my email y, which is my dependent variable, is basically integer. So I try to convert into a factor, and so that it enables R to perform the SVM through the classification technique. So that's basically converting my integer value into a factor variable. Uh, Now there are there are like total of uh, 4,601 data points. Okay, but since SVM is kind of a larger machine learning technique and it takes time to build a model, I'm trying to take a sample of that data of around 1,000 observations, and so that the model is built much faster. So that's the reason I've taken 1,000 observations just to build the model faster, because it would take a much larger time if I try to build it on it. 4,000 data points, and larger obviously the number of observations, the larger is the time taken. Again, given the fact that SVM is kind of a advanced ML technique and it usually works on number of iterations to find out the right hyperplane. Okay, so the next thing is about these few chunk of lines. So let's try to also give you an understanding of what is basically training and testing data set. Okay, but before that, do you guys have any questions? Yeah, Hitesh is aware of CA tools. So any questions still here, guys? Are you all with me till here? Any questions, any queries that you have? Okay, I will continue to assume your silence to be no. So basically, and I try to introduce you the concept of training and a testing data set. What is the advantage of converting as a factor? So if you remember, Abhishek, so SVM is basically a classification technique, and a factor is basically, so initially my y was read as integer variable, so it was either 0 and 1, which is just like integer. So I need to convert into a factor because it's just like the two classes, 0 or 1. So that's the reason we convert into factor to enable SVM to take it as a factor and not just as integers. So if you integers, it will be additive, but if they are factors, they are not additive, right? So they are like two separate classes. So that's the reason we convert it to a factor. Okay. So basically, the concept of training and testing is nothing. It's basically dividing the data set into two parts. So, and one of the first parts, we basically build the model or we train the model. And in the second part, we basically predict the model, that how the model is doing. So if you, let's say, if you build the model in the entire data set, you do not have anything to basically to check upon, or to basically test how good your model has been. So in order to test that model of the model that you built, we do not use the entire data set. We keep a portion of the data into a test data set, which is basically to test the performance of your model. Okay. So this particular line of code, again, this tries to it is useful in producible in producing and reproducing your results. So since again these techniques basically works on iterations, so it's important to produce the same result every time. You cannot produce different results different times, and since it's iteration, sometimes the results are different. So in order to make your results constant, or enable R to produce same to the point results, we do a set seed, and this can be any number. This can be 1 to 1, 1 to 3, anything that you want to give. But just the point is that you need to give it every time the same number every time you build the model. So that's the usability of it. So that the set seed, this basically line of code basically divides the data into training and testing. So the split ratio is basically dividing the data into 60 and 40%. So my 60% of my data gets into trained data, and the rest, which is the 40% of the data, gets into the test data. So in my uh, test data, I have got 400 observations, I've got 58 variables, and in trained data, I've got 600 observations and 58 variables. Okay. So this is still here. We have basically divided my data into train and test, and so we are ready for building the model. Okay. So now this part of the code, which is like the registered DOMC, this basically increases the speed of SVM calculation. So I've been keep on telling that SVM is kind of a machine learning techniques. It works on repeated iterations. Uh, so in order to increase or enhance speed, I've used as the greater the number, it tries to increase the speed more. Okay. Now, so till here we have basically splitted the data. We read the data. We saw the structure. We figured the names of the variables, and we then divided the data into training and testing. And now, so there are two parts of, or maybe the three parts of SVM. So the first part is basically trying to build the sizest function. This sizest function does nothing. It basically helps you to get the sigma values. The sigma values uh, is used when it's basically this the sigma grid. This is basically it as having the two grids, which is the sigma and the C. So what's the role of the C parameter? Is basically uh, it enables your SVM to get the optimal hyperplane. So how do you choose the hyperplane? So it is this through the C parameter, and the larger the value of the C, the optimization will choose a smaller margin hyperplane. So basically the margin that we talked about previously. So basically uh, this one, this part of it, which had the maximum margin. So the greater the value of the C, the smaller is the margin of the hyperplane, and a small value of C, it will give you a very larger margin. So it's kind of a iterative process of what you want to give, but it's okay to choose a somewhat a smaller feature, or a smaller value of a C, or the C parameter. So the greater the number you give, the greater is the sigma generated, and the C, and the number of times it iterates. So the number of times, if you increase this value, the number of sigma and the C parameter increases, and as a result, your SVM model also increases in your time limit. So basically, the C parameter is basically tells your SVM of what is the optimization value, and what would be the hyperplane, and what would be the margin of the hyperplane. So this C basically controls the margin of the hyperplane, which is basically the difference between your support vectors, or which are like your zeros and ones. So so this grid enables you to pass on the data to the SVM, and basically
Guys, good evening. I think Arpindu just logged out or might have disconnected. He's just logging back. Just hang on there.
Hi guys, very sorry. I just didn't realize that somewhere my internet connection was bad and it got disconnected. So okay. Okay, so yeah, so I think colleague said me just there was the lag of I think 5 minutes. So just let me know till where we were doing. So just let me know. So I basically had run the model. So in the next in the 5 minutes, just let me know till where you didn't the last point do you guys hear? So if you can help me to catch up, any of you, Abhiroop, Abhishek, Arjit, if any one of you can let me know till where did you guys followed. Rerun the model. Okay, I will rerun the model. Uh, Digest. Okay, perfect. Thank you, Satya. Yeah. So okay. So let me try to explain it again. So here you go. So basically, what we did is again. Let me show you. So we first the first step was setting the path. Then I had called a few libraries which were important for installing or running SVM. Okay, so these were like four libraries which were important. Then I basically did nothing, and I basically read the data sets in R. Okay, so the first what was my the original data set, and the second was my names data set, which basically were my columns of my data. Okay, And then we basically, as you had seen the data, the original data did not have the name, so I had just applied the names taking it from the data name, right? So, and then what we did is basically converted my y variable, which was my dependent variable, into a factor. Okay, and okay, I will. So, and so I converted this into factor. And the next step was basically dividing taking 1,000 data points or 1,000 rows of my data. Uh, why did I do this? I did this because to run a smaller SVM model, okay, and so that the model does not take a larger time, because originally the data set has around 4,500 observations, 4,600 observations to be exact. So I took a smaller sample of that. And then basically I divided the data into training and testing. So training and testing was basically meant to, like, I built the model on a training data set, and I use the model from the training data set to predict into a testing data set. So this is basically to check whether my prediction is good or not. Okay. And then basically what we did is try to, so using this function is basically increases the speed of SVM calculation. So this package called a DUMC package, this is basically enhances the speed of SVM calculation. So this was basically used for that. And uh, these two couple of functions, okay, so this basically tries to compute your sigma, okay, your sigma. So this sigma gets computed through this function, and this sigma is computed to the trained data. And this SVM grid is nothing. So I will explain you this SVM grid. So this is basically your a matrix of your sigma and C. And what the C or the tuning parameter does is that it helps you to find the optimal hyperplane. So since SVM essentially is kind of an optimization problem, or which basically maximizes the distance between or maximizes the margin distance, right, between the two classes of output. So the C parameter basically gives you the various threshold on which to to run the SVM, and to see that which hyperplane should be brought about. So if you give a very smaller value of C, so this C gets calculated through this sigmoid function and through this parameter dot C. And if you increase the number of parameters, let's say if you keep it, let's say 9 or 10, so what it will do is basically it will increase the grid, or in terms of increase the combinations of your C and sigma. Uh, I chose basically a kind of a medium range parameter here, and so that we do not take a very large time also, and we do not also take a very smaller hyperplane also, because if you choose a very smaller value of C, it will choose a very large margin, and if you choose a large value of C, it will try to bring in the smaller margin, right? So the point of doing this is that the number of times you increase, the more is the time it will try to build the model. The other drawback is that it can overfit your model, or it will try to read your model very, very finely. And in that case, it may perform or it may not perform well in your test data set. So it's advisable to choose something in between, and it's again a hit and trial, and you can choose the various combinations of .c and see that uh, how is my model performance varying. So this SVM grid is basically gives you the tuning parameters, or the parameters to find the hyperplane, which is basically this. So this hyperplane, right? So this hyperplane is basically available through your SVM grid. And then comes your modeling equation, which is basically using your train function. uh, this train function depends upon your caret package, and it uses your dependent variable, which is your y. It uses your train data. It uses the method, which is your svm radial, which is basically your support vector machine function. And this part pproc basically scales down or normalizes all of your independent variables, so that none of the independent variables has a larger impact on your y. And this tune grid, as I said, the tuning parameters are provided by your SVM grid, which is this grid, essentially. And this TR control, this basically stands for your train control, and it's a method of repeated CV, which stands for repeated cross validation. So a repeated cross validation is basically dividing your data set into number of times. So here mentioned repeat 5. So it basically divides your train data also 5 times and tries to build the model in each of these 5 data sets. And so it's basically, again, kind of machine learning technique. Since it's a machine learning technique, it will build a model n times, where n here is basically 5. And again, if I run the model again for you guys, so it takes a certain time to build this model, because even though we have taken 1,000 data points, and even if I'm not taken a very large value of C, but still, given that many observations also, SVM takes a kind of a larger time. The objective here, or basically the final outcome here, is to predict my dependent variable. And the outcome here, basically how we will assess the outcome, is basically how well is my dependent variable predicted. So if I had my y equals to 0, right? So whether if I had my y equals to 0 in my test data, or 1, right? So I will get something from my prediction, and I need to see that whether my prediction is accurate and whether it is also giving me 0 or 1. So this is what SVM will bring about, and this is what it will come out in terms of this modeling technique. Okay. So okay, and the floor to you guys. Any queries that you have till here? Abhishek, Satrajit. Was it like clear to you guys about in terms of the sequence of the coding that we followed? Okay. So okay, I think maybe I had changed these SVM, and that's the reason it's showing a bit of a larger time, taking a larger time. So in terms of what I choose about, or what I maybe I will just stop this, or okay. And I had the model built already. So when I was offline, so I can show you the results through this, hopefully. And now I can see the matrix that I was showcasing you. So basically, this is the kind of output that I get. Okay. So how to analyze this output? This is called the confusion matrix. So this is basically your prediction, and this is basically your original. So 228 of the zeros were actually predicted, were accurately predicted. 31 times the one was predicted your 0, and 128 times your 128 times your 1 was predicted accurately, and 13 times your 0 was predicted as 1. So your sensitivity is basically the probability of predicting y equals to 1, which is high, which is like 94%, and your overall accuracy is around 89%, which is quite good, right? So what we get basically out of this is that we get the predicted y. So what I can do right now is that I can maybe have my I can establish, I can just join my predicted output, a predicted dependent variable, and I can have it in my original data set. So if I just open this CSV, that is the output of your R file, and if you just see this, so these are like this is the part of this is my data set. These are like this is my test data set, and these are like my original Ys, and these are my predicted Ys. So this is my like the predicted Ys, and this is my original Ys of my test data set. So, and the accuracy of this, so basically this confusion matrix tries to analyze that whether this is equal to this, and tries to establish a matrix of the true and the false. So if you see here, so I've got a couple of false, and the mostly it's true, right? So there are around 128 which are true, which is basically this matrix that we have here. This matrix. Okay, so this is basically what a SVM does and how the prediction happens. So the fundamental agenda is about dividing the classification or classifying the data into two sort of categories and trying to find the hyperplane. The basic objective or the basic approach is about optimizing the margin, which is the distance between the two support vectors, and which are the variables, or using the variables, finding that right hyperplane using an n-dimensional place where n represents my number of independent variables. And the outcome here is basically my prediction of zero and of my dependent variable. And as we see that SVM does quite a good job in terms of predicting my outcome, and it achieves overall accuracy of 89% and a sensitivity of around 94%, which is quite good. And the outcome, or how this can be used, is that if you have these features, you can always use it to predict that whether the email coming to your mailbox is either a spam or a non-spam. So it can be used like Gmails, which they can really flag out, and they can move it to your spam box. So this is how like these the service providers like Yahoo or a Gmail kind of it does analysis of the emails that is bringing into email box and classifying them into spam or non-spam. So that's basically this SVM, and that's how it can be applied in ours. So I hope you guys understood the concept, and also the part of the coding, the small part of the coding that we did in art, and yeah, it's open to questions. So if you want to ask any questions, that I can. I'm really looking forward to that in case you have any questions. So we have a few of you left, but just feel free to ask me. Abhishek, Satrajit, Abhiroop, Zabran, and others as well. So any questions that you have? Jaspal, Buddhadev, Anupama. Did you like the concept of SVM? Did you understand the concept of SVM? So I would say broadly it could be introductory platform for you, and you can always connect to me. So this is my email ID. If you want to connect to me regarding any resources about it, I will be happy to help. Okay. And let me know. So yeah, so but I really expect something from you guys. Anything that you want to ask? Abhishek, yeah, you can drop me email regarding the same. and I can forward you certain case studies which you can practice. You can drop me an email and I will send you the same. Anything else? I can send you certain more resources also. So if you want to read more about it, I can send you a few more resources, which gives a more detailed understanding of SVM. Okay, so I again, so I feel that you do not have any more questions. And in case you have, you can always write down to me. Possibly if you do not have something in your mind right now, but you can always feel free to connect to me at my email ID. And I hope you enjoyed and more importantly understood the concept. And you at least understood the power of a advanced ML technique like SPM, which does really well in terms of predicting. So as I said, there are various classification and regression techniques used in the industry, but SVM as a technique is an emerging technique, and it's a kind of a advanced ML technique. Um, and given the pros and cons is that it's very good in predictive power, but it's very it's a time taking and it's an intensive technique. So that's the reason it cannot be applied on scale, and there are people who are trying to make it much more scale friendly or production friendly. But it's really good in terms of using it for prediction. So yeah. So having said that, in case you do not have any questions, I would like to end the webinar here. So again, if you have any questions, please you can write down in the Dropbox or in the chat box right now, and I will be really happy to answer. Satyajit, Abhijit, Abhishek, anything else? Buddhadev, Zabran. Okay, so okay. In case you do not have, so thank you guys for spending this time with us, and you can drop me email again, and we will be again having another short webinars on techniques related to machine learning, and it would be great for you guys to join and have experience. Yeah. So yeah, thank you guys, and have a good evening, and all the best. Yeah. In case if you wanna connect to me, you can always connect at painted.com@gmail.com. Yep. Thank you.